Welcome back in the lecture series on topic Ionic Equilibria. In last lecture, we have studied about Bronsted-Lowry concept of acid and base. And this theory is based on proton transfer from one atom to one substance to another substance. Now, according to this theory, acid is a proton donor and base is a proton acceptor. One drawback of this theory that this theory cannot explain the reaction between acidic oxides and basic oxides. Acidic oxides such as sulfur trioxide, sulfur dioxide or carbon dioxide, and basic oxides such as magnesium oxide, barium oxide, calcium oxide, etc. And another drawback of this theory, that is those substances which do not have proton to donate, nature of such substances cannot be explained on the basis of Bronsted-Lowry concept. For example, BF3 molecule, boron trifluoride molecule, aluminum trichloride molecule. The nature of these substances cannot be explained on the basis of Bronsted-Lowry theory. You have also studied Arrhenius theory. So Arrhenius theory as well as Bronsted-Lowry theory of acid and base, both are limited to substance which contain proton, and therefore scientist Jean Lewis in 1923 proposed a more generalized concept of acid and base. And according to this concept, that is Lewis concept of acid and base, acid is any species such as molecule or ion that accept a sharing an electron pair is called as Lewis acid. मग इलेक्ट्रॉन केव्हा ॲक्सेप्ट करेल एखादा सबस्टन्स, तर त्याच्याकडे एम्प्टी ऑर्बिटल असलं पाहिजे किंवा व्हेकंट ऑर्बिटल असलं पाहिजे किंवा इलेक्ट्रॉन डिफिशियंट साइट्स असल्या पाहिजे. सो एनी सबस्टन्स which has an empty orbital that can accommodate a pair of electron act as a Lewis acid. And base means what? Any species, maybe molecule or ion, that donate a share in an electron pair is called as Lewis base. So any substance that has an unshared pair of electron, means just lone pair of electron, they can act as a Lewis base. For example, ammonia. Here ammonia has a lone pair, and ammonia can donate a lone pair to boron trifluoride molecule. So here ammonia act as a base and boron trifluoride act as a acid. And when ammonia, that is nitrogen of ammonia, donates its lone pair to boron, it forms what? A bond, coordinate bond between ammonia and BF3 molecule and form addition compound. So acid base reaction, according to Lewis theory, this means what? In acid base reaction there is a donation of pair of electron from Lewis base to Lewis acid to form what? Coordinate bond between them. So coordinate bond means bond in which both electron in the shared pair comes from one atom. एकाच ॲटम कडून दोन्ही इलेक्ट्रॉन जे बॉन्ड फॉर्मेशनसाठी लागणार आहेत ते कॉन्ट्रीब्यूट केले जातात. फॉर एक्झाम्पल, सी हियर इन दिस एक्झाम्पल, ammonia donates its electron pair to electron deficient hydrogen ion, and hydrogen ion accept this electron pair, and therefore nitrogen, the bond between the nitrogen and hydrogen is coordinate bond, and here the coordinate bond is generally represented like this, pointing an arrow pointing from donor to acceptor. So it is generally represented by an arrow pointing from donor to acceptor. And this bond is also called as a dative bond. Coordinate bond is also called as a dative bond. Now here are some examples of acid and Lewis acids and Lewis bases and reactions of acid and base. So here hydrogen ion is an electron acceptor and ammonia is an electron donor. So it is a base, and when these two reacts in form of addition compound, that is NH4 ion is formed. It is called as an adduct also. So an acid is an electron pair acceptor according to Levy's acid base theory, and base is an electron pair donor according to Levy's acid base theory. So here BF3 molecule accept electron, it is an electron deficient molecule. It accepts an electron pair from ammonia, so it acts as a acid, whereas ammonia act as a base, and they form a bond, coordinate bond between nitrogen and boron in addition compound. So let us understand this statement, that is all Bronsted bases are also Levy's bases, but all Bronsted acids are not Levy's acid. The most important statement in this topic, that is all Bronsted bases are also Levy's bases, but all Bronsted acids are not Levy's acid. Now you know that you have studied Bronsted acid base theory. So according to Bronsted-Lowry theory, base is proton acceptor, and according to Levy's base acid base theory, Levy's base is a electron pair donor. ब्रॉन्स्टेडच्या थेअरीप्रमाणे बेस हा काय असतो, प्रोटॉन ॲक्सेप्टर असतो, आणि लेविसच्या थेअरीप्रमाणे इलेक्ट्रॉन पेअर डोनर असतो. सो लेविस बेस कंटेन वन ऑर मोर लोन पेअर ऑफ इलेक्ट्रॉन अँड देअरफोर दे कॅन ॲक्सेप्ट अ प्रोटॉन. त्यामुळे ते काय करू शकतात, दे कॅन ॲक्सेप्ट अ प्रोटॉन. दॅट मीन्स ब्रॉन्स्टेड base, according to Bronsted theory, base is a proton acceptor, so they can accept what, that is Levy's base can accept a proton, and therefore the all Bronsted bases are also Levy's bases, but all Bronsted acids are not Levy's acid. That means what, Levy's acid is a substance which can accept a sharing an electron pair, and Bronsted acids are those which can give a proton, which can donate a proton. And you know that HCl, H2SO4, these are examples of Bronsted acid, but they are not capable of accepting a pair of electron. Therefore all Bronsted acids are not Levy's acid, but all Bronsted base are Levy's base. Now, so we see some examples of Levy's acid. That is molecules in which the central atom has incomplete octet. They can act as a Levy's acid. That means the molecules in which the central atom has only 6 electrons around it. For example, aluminium chloride, boron trichloride or boron trichloride. All these are the examples of what, Levy's acid. Or the simple cations, that is all cations are electron deficient, and therefore all cations, simple cations, can act as a Levy's acids. For example, Ag ions, H ions, they have greater tendency to accept electrons. See here in this reaction, Ag ion accept electron pair from ammonia and forms a addition compound, acid base addition compound is formed. Here also ammonia donates its electron pair to acid, that is Levy's acid, and hydrogen ion, that is proton, and form NH4 ion. So third, that type, that is molecules in which the central atom has empty d orbital, they can also act as a Levy's acid, and due to presence of empty d orbital, the central atom in these molecules can expand their octet by accepting the electron from the other substance, and therefore they can also act as a, such a molecules can act as a Levy's acid. For example, SiF4, and silicon is the central atom. So silicon has atomic number 14. So its electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p2. And as third shell is open, the d orbital, 3d orbital is empty in case of silicon, and therefore it can expand its outer octet and accept the electron. So SiF4 when treated with fluorine, it gives you SiF6, or phosphorus pentafluoride PF5, or SnCl4. All these are such a type of a molecule in which the central atom has empty d orbital. And fourth type of Lewis acid, that is molecules in which atoms of different electronegativities are joined by multiple bonds. Here is an example of carbon dioxide. Formula of carbon dioxide, CO2. C double bond O, double bond joined by multiple bond. When in presence of the Lewis base, one pi bonded electron from this carbon oxygen bond shifted towards oxygen, that is more electronegative atom, and OH group attack on this carbon and forms what? The OHC bond, and thus carbonate ion is formed, HCO3, that is bicarbonate, not carbonate, bicarbonate ion is formed. Another example, that is sulfur dioxide. Also the example of molecule in which atoms of different electronegativities are joined by multiple bond, and such a molecules can act as a Lewis acid. Like that, Lewis base is neutral spaces having at least one lone pair of electron. Such a molecule can act as a Lewis base. For example, ammonia, NH2, alcohol, ROH, water, all these are the neutral spaces which can act as a Lewis bases, as well as negatively charged spaces or anions such as chloride ion, cyanide ion, hydroxyl ion, fluoride ion, they can act as a Lewis base. So chloride ion, when it is treated with BCl3, it acts as a Lewis base, donates its lone pair to boron and forms what? A coordinate bond between chlorine and boron. So it is an example of Lewis base. So thus we have studied three theories of acid and base: Arrhenius theory, Bronsted theory and Lowry theory. So according to Arrhenius theory, acid produces hydrogen ion in aqueous medium and base produces OH ion in aqueous medium, that we have studied in detail. According to Bronsted-Lowry theory, acid is a proton donor and base is a proton acceptor. And according to Lewis theory, acid is a electron pair acceptor and base is electron pair donor. So all these acid-base theories we have studied. Now we will study the next point, that is the ionization of acid and base in my next lecture. Thank you.